September 17th, 1944. Kummersdorf Proving Grounds, 25 miles south of Berlin. Oberingenieur Klaus Hartmann watched through field glasses as a captured American rifle was mounted in the test fixture. The morning air carried the acrid smell of cordite from earlier firing tests. Around him, 3 Wehrmacht officers and 2 civilian engineers from Mauser waited in silence. They had come to witness something that German High Command refused to believe: an American rifle that could fire 8 rounds without manual operation of the bolt. Not a machine gun. Not an automatic rifle like the BAR. An ordinary infantry rifle issued to every American soldier that somehow eliminated the fundamental limitation of bolt-action firearms. Hartmann had examined captured American equipment before. Sherman tanks with their reliable engines and simple maintenance. Jeeps that could traverse terrain German vehicles could not. Radios that worked when German radios failed. Each piece of equipment told the same story. American industry had found ways to make weapons that performed not through superior engineering elegance, but through brute simplicity and mechanical reliability. But this rifle, this M1 Garand, represented something different, something that challenged everything German military doctrine assumed about infantry combat. The test began. The pneumatic ram cycled the trigger mechanism. The rifle fired. The bolt opened automatically. A spent cartridge ejected. A new round chambered. The bolt locked. The rifle fired again. 8 rounds in less than 6 seconds. No human hand touched the weapon between shots. When the 8th round fired, an empty metal clip ejected with a distinctive ping, and the bolt locked open. Hartmann lowered his field glasses. He had just watched a weapon fire faster than 3 trained riflemen with Karabiner 98 Kurz rifles could manage, and the American rifle had done it mechanically, without fatigue, without error, without the skill that took German soldiers months to develop. Major Wilhelm Brandt, the Wehrmacht observer, spoke first. How is this possible? The recoil forces alone should damage the mechanism. Hartmann had spent the previous evening studying the captured rifle's design. The Americans use a gas-operated system. Propellant gases are tapped from the barrel and redirected to cycle the action. The shooter never touches the bolt between shots. And this is issued to every American rifleman? Brandt asked. According to intelligence reports, yes. Every infantryman. Not specialists, not elite units. Every soldier. The implications hung in the air like smoke. German infantry doctrine was built on the assumption that both sides used bolt-action rifles requiring manual cycling between shots. Fire superiority came from machine guns. Riflemen provided supporting fire and occupied positions between machine gun teams. But if every American rifleman could fire at rates previously reserved for automatic weapons, if American infantry squads could put 3 times as many rifle rounds downrange as equivalent German units, then every tactical calculation became obsolete. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of how America came to field the world's only standard-issue semi-automatic rifle, while Germany, Japan, Britain, and the Soviet Union relied on bolt-action designs begins not with American ingenuity, but with American failure. November 11th, 1918, the Great War ended. American forces had deployed to Europe equipped primarily with bolt-action Springfield rifles, a superb weapon derived from the German Mauser design. But Springfield Armory had produced only 265,000 rifles during the war, nowhere near enough to arm the American Expeditionary Force. The shortfall forced the United States to equip hundreds of thousands of soldiers with British Enfield rifles manufactured under license by Remington and Winchester. The humiliation of being unable to arm American soldiers with American rifles burned in the memory of army planners. The lesson was clear. The next war would require weapons designed for mass production, weapons that could be manufactured quickly by semi-skilled workers, weapons that would give American soldiers a decisive advantage. The search for that advantage led to a small workshop in Massachusetts, where a self-taught Canadian immigrant was about to change warfare forever. January 1st, 1888, Saint-Rémy, Quebec. Jean Cantius Garand was born on a small farm 17 miles south of Montreal. Nothing in his early life suggested he would create what General George Patton would later call the greatest battle implement ever devised. At age 11, young Jean moved with his family to Connecticut when his father abandoned farming for textile mill work. By age 12, the boy was sweeping floors in a mill at Jewett City, but he was fascinated by the machinery around him. During breaks, he studied the mechanical looms, the steam engines, the precision gears that transformed raw cotton into finished cloth. By age 18, Garand worked as a machinist. His natural aptitude led him to tool and gauge making, skills that required both mathematical precision and mechanical intuition. He took correspondence courses at night, teaching himself engineering principles that most men learned only in universities. In 1916, at 28 years old, Garand turned his attention to firearms design. He submitted plans for a semi-automatic rifle to the United States Navy 2 years later. The Navy was impressed enough to request he continue his work at the Bureau of Standards in Washington. After a year and a half, Springfield Armory in Massachusetts offered him a position as a design engineer. What Garand found at Springfield shocked him. The legendary armory, which had given its name to the Springfield rifles that equipped American forces in World War I, was hopelessly outdated. The Springfield Model 1903 was a superb rifle, accurate and reliable, but it was designed to be hand-fitted by skilled armourers working at a leisurely peacetime pace. Modern warfare demanded weapons that could be mass-produced quickly by semi-skilled workers using machine tools. Garand recognized that the next war would be won by the nation that could arm its soldiers fastest with the most effective weapons. The rifle he envisioned would fire every time the operator pulled the trigger, without requiring manual cycling of a bolt between shots. This semi-automatic operation would triple the rate of fire compared to bolt-action designs. It would allow soldiers to maintain their shooting position and sight picture between rounds. Most importantly, it would shift the balance of firepower decisively toward whichever side possessed it. Garand's path to success was anything but straight. His first designs used primer actuation, where the force of the primer explosion cycled the action. This proved unreliable. He switched to gas operation, tapping propellant gases from the fired cartridge to power the mechanism. In 1929, his design won Army acceptance trials. Victory seemed certain. Then politics intervened. General Douglas MacArthur, Army Chief of Staff, insisted the rifle use the existing .30-06 Springfield cartridge rather than the newer 276 Pedersen round for which Garand had designed his rifle. MacArthur's reasoning was economic. The Army had millions of rounds of .30-06 ammunition in storage. Starting fresh with a new caliber would cost millions of dollars and delay deployment for years. Garand returned to his workshop and redesigned the entire rifle for the heavier, more powerful .30-06 cartridge. The process took 3 years. On August 3, 1933, his redesigned rifle was officially designated the United States Rifle, caliber .30, M1. On January 9, 1936, the Army adopted it as the new standard infantry weapon. The first production M1 Garand was successfully proof-fired, function-fired, and fired for accuracy on July 21, 1937. Production began that September at a rate of 10 rifles per day. By January 1940, Springfield Armory was producing 100 per day, but this was nowhere near enough for a nation watching Europe descend into war. On September 20, 1939, the same month Germany invaded Poland, Winchester Repeating Arms received a contract to manufacture M1 Garands. The company was less than enthusiastic. Winchester engineers thought the Garand was too complex, too expensive to produce. Relations between Winchester and Springfield Armory personnel became openly hostile, with each side accusing the other of incompetence. Despite the friction, both manufacturers ramped up production as war clouds gathered. By December 7, 1941, when Japan attacked Pearl Harbor American factories were producing rifles at unprecedented rates. The M1 Garand became a top priority overnight. January 1942 saw Springfield Armory producing 1,130 Garands per day. Production peaked in January 1944, when Springfield alone manufactured 122,000 rifles in a single month. This translated to 3,936 rifles per day, or 164 rifles per hour. Winchester added another 513,000 rifles between December 1940 and June 1945. By war's end in August 1945, over 4 million M1 Garands had been produced. The United States was the only major power to field a semi-automatic rifle as standard infantry equipment. Every other army, British, German, Soviet, Japanese, Italian, relied primarily on bolt-action designs. The tactical implications of this difference cannot be overstated. A rifleman with a bolt action must perform multiple steps between each shot. Pull the bolt handle up and back, ejecting the spent cartridge. Push the bolt forward, chambering a new round. Push the bolt handle down, locking it in place. Raise the rifle back to shooting position. Reacquire the target. Aim. Fire. The entire cycle takes 4 to 6 seconds for a trained soldier, longer under combat stress. The M1 Garand eliminated most of these steps. Pull trigger, rifle fires. Gas pressure from the fired cartridge operates the mechanism automatically. Bolt opens. Spent case ejects. New round chambers. Bolt locks. Total time, 1/5 of a second. The shooter never moves his hands, never drops his aim, never loses his sight picture. Pull trigger again. Another round fires. The fire rate advantage was dramatic, but not immediately obvious. A single shot from a Garand took the same time as a single shot from a bolt-action rifle. The difference appeared when firing multiple, in rounds. An M1 Garand could deliver 8 aimed shots in 20 seconds. A German Karabiner 98 Kurs required almost a full minute for the same number. In the chaos of combat, this translated to overwhelming superiority. American infantry could put 3 times as many rounds downrange as their opponents in any given firefight. They could suppress enemy positions more effectively. They could break up counterattacks before they built momentum. They could win firefights through sheer volume of accurate fire. But the M1 Garand was not without limitations. The 8-round N-block clip system drew criticism from the moment of adoption. The rifle could not be easily topped off mid-magazine like bolt-action designs. Soldiers had to either fire all 8 rounds or manually eject a partially full clip, wasting ammunition. The distinctive metallic ping when an empty clip ejected became legendary, though whether enemy soldiers could actually hear it in combat remains debated. The rifle was also heavier than most bolt actions. Fully loaded with sling and bayonet, an M1 Garand weighed approximately 11 pounds. A German Kar 98K weighed 8.5 pounds. Over the course of a 20-mile march, that 2.5-pound difference felt significant. Yet these drawbacks paled beside the weapon's advantages. The Garand was ruggedly built, able to function in conditions that disabled more finicky designs. It was accurate out to 500 yards. Its powerful 30-06 cartridge delivered decisive stopping power. Most importantly, it put devastating firepower in the hands of every infantryman, not just specialists. Back at Kummersdorf Proving Grounds, the German engineers continued their examination of the captured M1 Garand. Oberingenieur Hartmann field-stripped the rifle, laying out each component on a canvas tarp. Major Brandt watched as the receiver was removed, revealing the elegant simplicity of the gas system. "How many moving parts?" Brandt asked. Hartmann counted carefully. "Approximately 54 major components, fewer than I expected." "And it functions reliably in combat conditions?" According to interrogation reports from captured American soldiers, yes, the rifle operates in mud, sand, extreme cold, extreme heat. The gas system is self-cleaning to a degree. Carbon buildup does not prevent operation. Brandt picked up the 8-round clip. The spring steel gleamed even in the overcast morning light. This clip system, it seems primitive. Why not a detachable box magazine? Weight and simplicity, Hartmann replied. A detachable magazine would add complexity and points of failure. The N-block clip is disposable. If it fails, the soldier inserts a new one. There is nothing to maintain, nothing to lose. The logic was undeniable. Every aspect of the M1 Garand's design prioritized reliability and ease of manufacture over theoretical perfection. The rifle was not elegant. It was effective. Germany had not ignored semi-automatic rifle development. Quite the opposite. German weapons designers had been pursuing self-loading rifles since the early 1900s, decades before the Americans. The problem was that German engineers consistently prioritized mechanical sophistication over practical reliability. November 19, 1941, Walther Waffenfabrik in Zella-Mechlis, Germany. The Gewehr 41 rifle entered production after years of development. The weapon was Germany's answer to reports of Soviet semi-automatic rifles appearing on the Eastern Front. German High Command demanded a semi-automatic rifle for Wehrmacht issue. The specifications they provided, however, doomed the project from the start. The rifle could not have a gas port drilled in the barrel. This was considered unacceptable because it would weaken the barrel and complicate manufacturing. The rifle could not have moving parts on top of the barrel that might interfere with the soldier's line of sight. The rifle had to use the standard 7.92 by 57 mm Mauser cartridge, with no modifications. These constraints forced German designers into extraordinarily complex solutions. The Walther version, designated Gewehr 41W, used a muzzle trap system. Gas pressure at the muzzle was captured by a cone-shaped device that drove a piston rod running the length of the barrel. The system was ingenious from an engineering standpoint. It was also heavy, awkward, unreliable, and difficult to manufacture. The rival Mauser design, designated Gewehr 41M, used an even more complex toggle-locked system, similar to the Luger pistol. Both rifles weighed over 11 pounds. Both required extensive hand-fitting. Both malfunctioned frequently in field conditions. Production of both versions began in 1941, but by 1942, reports from the Eastern Front were devastating. The rifles jammed in cold weather. They jammed in mud. They required constant maintenance that frontline soldiers could not provide. German. Soldiers who captured Soviet Tokarev SVT-40 semi-automatic rifles often preferred the Soviet weapon to their issued Gewehr 41 seconds. The humiliation of German soldiers preferring enemy weapons prompted a redesign. The result was the Gewehr 43, which finally abandoned the prohibition on gas ports and adopted a gas-operated system similar to the Soviet Tokarev. The Gewehr 43 entered production in October 1943. It was a competent rifle, accurate and reasonably reliable, but by late 1943, Germany's industrial capacity was collapsing under Allied bombing. Raw materials were scarce. Skilled labor had been drafted into the Wehrmacht or killed in air raids. Factories operated under constant threat of destruction. Total production of the Gewehr 43 from October 1943 to May 1945 reached approximately 400,000 rifles. This sounds impressive until compared to American production. In the same 18-month period, Springfield, Armory and Winchester produced over 2 million M1 Garands. Germany produced one semi-automatic rifle for every 5 that America manufactured, and German production came far too late to influence the war's outcome. More importantly, the Gewehr 43 was never issued as a standard infantry rifle. It was classified as a specialist weapon, issued primarily to designated marksmen and squad leaders. The vast majority of German infantry, more than 95%, fought the entire war armed with bolt-action Karabiner, 98 Kurz rifles, designed in the 1890s. The contrast with American doctrine could not have been more stark. America equipped every infantryman with semi-automatic rifles. Germany equipped specialists only, and only when industrial capacity allowed. The decision reflected fundamentally different military philosophies. German doctrine emphasized individual marksmanship and fire discipline. Each shot was supposed to be aimed carefully at a specific target. Semi-automatic rifles, German theorists argued, would encourage soldiers to waste ammunition with rapid, unaimed fire. American doctrine emphasized volume of fire and fire superiority. American planners believed that keeping enemy soldiers pinned down with continuous fire was more valuable than carefully aimed single shots. Semi-automatic rifles allowed American infantry to achieve fire superiority even when outnumbered. Combat results proved the American philosophy correct. June 6, 1944. Omaha Beach, Normandy. Private First Class Henry Warner from Cleveland, Ohio, struggled through chest-deep water toward the beach. Around him, men were falling as German machine gun fire swept the landing craft. His M1 Garand, held high above the water, represented the only offensive weapon in his immediate vicinity. He had fired the rifle perhaps 20 times during training. He had never fired it in combat. Within the next 3 hours, that inexperience would not matter. The semi-automatic action would compensate for his lack of skill. Warner reached the beach and threw himself behind a steel obstacle. German fire was coming from a concrete bunker, 200 yards up the slope. He could see the muzzle flash of the MG-42 machine gun. He raised his Garand, aimed at the general vicinity of the bunker, and began firing. Pull trigger, rifle fires. Aim shifts slightly from recoil. Pull trigger again, another round fires. He emptied the 8-round clip in less than 10 seconds. The metallic ping of the ejecting clip was lost in the chaos of battle. He fumbled a new clip from his cartridge belt, inserted it, released the bolt, and continued firing. Around him, other soldiers with Garands were doing the same. The combined fire from perhaps 20 American riflemen created a sustained barrage that forced the German machine gun crew to take cover. The MG-42 fell silent for crucial seconds. American soldiers used those seconds to advance up the beach. The Germans had resumed firing, but more Americans had reached cover. More Garands opened fire. The cycle repeated throughout the morning. American infantry would pin German positions with rifle fire, advance during brief lulls, pin the position again, advance again. The M1 Garand made this tactic possible. A force armed with bolt-action rifles could not have generated sufficient suppressive fire. Each rifleman would have been working his bolt manually, creating gaps in fire that alert defenders could exploit. Private Warner survived Omaha Beach. In later interviews, he attributed his survival to his rifle. "I didn't have to think about operating the bolt. I just aimed and pulled the trigger as fast as I could. The rifle did everything else. If I'd had to work a bolt between each shot, I'd have been killed in the first 5 minutes." His experience was repeated thousands of times across all theaters of war. American soldiers who might have been overwhelmed by better-trained opponents instead prevailed through superior firepower. The semi-automatic rifle multiplied effectiveness in ways that training alone could not match. The German military's response to the M1 Garand was confusion and denial. Intelligence reports from captured American equipment reached Wehrmacht headquarters throughout 1942 and 43. Each report described the same weapon, a semi-automatic rifle issued to all American infantry. Each report emphasized the firepower advantage this created. German High Command struggled to accept what the reports indicated. How could America, which had entered World War I unable to arm its own soldiers, now field semi-automatic rifles as standard equipment? How could American industry, which German intelligence had consistently underestimated, produce millions of complex weapons? The answer lay in industrial capacity and strategic priorities. America's factories, protected by 2 oceans from enemy bombing, operated at full capacity throughout the war. Raw materials flowed freely from American mines, farms, and oil fields. Skilled workers trained new employees who trained others in turn. The supply chain, from steel mills to final assembly, functioned without disruption. Germany's industry operated under increasingly desperate conditions. Allied bombing destroyed factories faster than they could be rebuilt. Raw materials became scarce as Germany lost access to conquered territories. Skilled workers were drafted into military service to replace casualties on the eastern and western fronts. By 1944, German industry was reduced to producing simplified weapons from inferior materials using slave labor. The Volkssturmgewehr 45, a crudely stamped sheet metal weapon, represented Germany's industrial collapse. It was designed to be manufactured by untrained workers in workshops rather than factories. It could fire perhaps 1,000 rounds before mechanical failure. Compared to the meticulously machined M1 Garand, which could fire tens of thousands of rounds with proper maintenance, the contrast was absolute. September 19th, 1944. 2 days after the Kummersdorf testing, Oberingenieur Hartmann submitted his report to Wehrmacht High Command. The document was marked Geheim, secret, though its contents would have surprised no one familiar with combat reports from the front. The American M1 Garand rifle represents a significant tactical advantage. Its semi-automatic operation provides individual soldiers with firepower equivalent to 3 riflemen with manual bolt-action weapons. The rifle's design prioritizes reliability and ease of manufacture over mechanical elegance. It functions in adverse conditions that would disable more sophisticated designs. Most critically, the rifle is issued to all American infantry, not limited to specialists. This universal distribution of semi-automatic rifles gives American infantry units overwhelming fire superiority in small unit engagements. Hartmann's report continued with technical specifications, manufacturing estimates, and tactical recommendations. The conclusion was unambiguous. Germany lacks the industrial capacity to produce equivalent weapons in sufficient quantities to affect the war's outcome. Our focus should be on defensive tactics that minimize exposure to American firepower advantages. The report was filed. No action was taken. By September 1944, Germany's situation was beyond salvation through superior weapons. The industrial and manpower advantages that America and its allies possessed would have been decisive even if both sides had fielded identical equipment. But the M1 Garand ensured that American soldiers went into combat with a weapon that multiplied their effectiveness. Major Wilhelm Brandt, who had observed the Kummersdorf testing, was killed in action 3 weeks later during the Allied advance across France. His unit was overrun by American infantry, whose rapid, sustained rifle fire prevented German soldiers from organizing a coherent defense. Oberingenieur Klaus Hartmann survived the war and was interrogated by American technical intelligence teams. He told them that German engineers had recognized the M1 Garand's superiority as early as 1942, but that Germany's industrial situation made copying it impossible. He examined captured German weapons reports during his interrogation and noted that Wehrmacht intelligence had accurately documented American firepower advantages, but that this intelligence had been systematically ignored by commanders who refused to believe their opponents possessed superior technology. The story of the M1 Garand and Germany's failure to field equivalent weapons illuminates fundamental differences in how nations approached warfare. America treated war as an industrial problem. The side that could produce more weapons, more ammunition, more vehicles, more of everything, would eventually prevail. Individual weapon quality mattered less than the ability to equip every soldier with good enough equipment in overwhelming quantities. Germany treated war as a test of will and superior fighting spirit. German doctrine emphasized training, tactics, and technological sophistication. Germany produced weapons of extraordinary engineering complexity: the Tiger tank, the MG-42 machine gun, the Messerschmitt 262 jet fighter, each a masterpiece of design. But Germany could not produce these weapons in quantities sufficient to overcome Allied numerical superiority. The M1 Garand exemplified the American approach. The M1 Garand exemplified the American approach. It was not the most sophisticated semi-automatic rifle ever designed. The Soviet Tokarev SVT-40 had a detachable magazine. The German Gewehr 43 had superior accuracy, but the M1 Garand was reliable, manufacturable, and available. 4 million rifles reached American soldiers when they needed them. The firepower mathematics remained brutal and undeniable. One American rifleman with an M1 Garand could fire 24 aimed rounds per minute under combat conditions. One German rifleman with a Karabiner 98K could fire 12 to 15 aimed rounds per minute with excellent training, fewer under stress. The disparity meant that American squads of 12 men could generate more rifle fire than German squads of 10 men, even before accounting for American advantages in automatic weapons and artillery support. Combat after-action reports from both sides confirmed the pattern. American units consistently reported winning firefights against numerically equivalent German forces. German units consistently reported being outgunned by American infantry, attributing this to American automatic weapons, when in reality, much of the firepower advantage came from semi-automatic rifles in the hands of every American soldier. November 8, 1944. Hürtgen Forest, Germany. Corporal Friedrich Becker of the Wehrmacht's 275th Infantry Division took cover behind a fallen tree as American rifle fire tore through the forest. The Americans were attacking through terrain so dense that neither side could see more than 50 yards. Becker's squad had prepared defensive positions, interlocking fields of fire, everything by doctrine. It did not matter. The Americans advanced in short rushes, each rush covered by devastating rifle fire from soldiers who never seemed to pause for reloading. Becker fired his Karabiner 98K 3 times, working the bolt smoothly despite cold fingers and mounting fear. Between his third and fourth shots, he counted at least 20 American rounds, impacting around his position. He could hear the distinctive sound of M1 Garands, that steady crack, 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 without the pauses that bolt-action fire produced. His squad leader was screaming orders, but Becker could barely hear over the volume of incoming fire. He raised his head to aim and saw an American soldier not 30 yards away, firing from the hip while advancing. The American's rifle barked continuously, 8 rounds in the time it took Becker to work his bolt twice. Becker fired, missed, worked the bolt. The American had taken cover. More American rifle fire came from positions Becker had not seen occupied seconds before. The Americans were moving during their own fire, something that should have been impossible. You could not advance and fire effectively with a bolt-action rifle. The manual cycling required 2 hands and disrupted aim, but the Americans were doing it anyway because their rifles did not require manual cycling. Becker's squad fell back. The withdrawal was supposed to be tactical, moving to alternate positions. It became a rout. American rifle fire followed them through the forest, steady and unrelenting. Of the 10 men in Becker's squad, 4 made it to the next defensive line. Becker survived the Hürtgen Forest. He was captured near Cologne in March 1945 and spent 2 years as a prisoner of war. In interviews conducted decades later, he remained adamant that American firepower superiority, specifically the semi-automatic rifles, had been the decisive factor in his unit's defeat. We were told we were better soldiers than the Americans, that our training was superior, that German discipline would overcome American numbers. What they did not tell us was that every American carried a rifle that fired as fast as 3 of ours. You cannot overcome that with discipline. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The M1 Garand's impact extended beyond individual engagements to strategic operations. American infantry divisions could advance faster than equivalent German divisions because American soldiers could suppress enemy positions with rifle fire alone without waiting for machine guns or artillery to be brought forward. This acceleration of tactical tempo gave American forces operational advantages that compounded over time. German forces, even when well-positioned and adequately supplied, found themselves unable to slow American advances because the firepower imbalance prevented them from holding defensive positions long enough to organize counterattacks. The Battle of the Bulge in December 1944 demonstrated this dynamic on a massive scale. German forces achieved complete tactical surprise, attacking through difficult terrain in poor weather that grounded Allied aircraft. German armor spearheads penetrated deep into American lines, but German infantry following the tanks consistently failed to hold ground they had taken. American infantry counterattacks, even when numerically inferior, generated such intense rifle fire that German positions became untenable. At Bastogne, the 101st Airborne Division, surrounded and outnumbered, held out for days largely because of firepower superiority. Every American paratrooper carried an M1 Garand. The sustained fire from these rifles broke up German infantry assaults before they could close to grenade range. German after-action reports from the Bulge repeatedly mention American rifle fire as a critical problem. One German regimental commander wrote that American infantry positions seemed to have twice as many riflemen as actually present because the volume of fire was so intense. The M1 Garand's significance becomes even clearer when examining Pacific theater operations. Japanese forces, armed primarily with the Type 99 Arisaka bolt-action rifle, employed human wave tactics that relied on closing to bayonet range before defenders could reload. These tactics had been developed against Chinese forces armed with a mixture of obsolete weapons. Against American forces with semi-automatic rifles, banzai charges became suicide. February 19, 1945. Iwo Jima. Private Robert Lawson from Minneapolis, Minnesota, crouched in a shell crater on the black volcanic sand. His M1 Garand was caked with sand, but the rifle still functioned. Around him, other Marines prepared for what veterans had warned would come at dusk, the Japanese counterattack. At 1,820 hours, Japanese infantry emerged from caves and fortified positions across the island. They charged American lines with bayonets fixed, screaming, officers waving swords. Lawson began firing. The semi-automatic action allowed him to track moving targets while firing continuously. He did not have time to think about his shooting technique. He simply aimed at the closest enemy soldier and pulled the trigger until that soldier fell, then shifted to the next target. The M1 Garand made this possible. A bolt-action rifle would have required him to drop his sight picture after each shot, work the bolt, reacquire his target. By that time, attacking soldiers would have covered significant ground. The Garand let him maintain continuous fire. Around him, other Marines were doing the same. The combined fire from perhaps 40 riflemen created a wall of bullets that shredded the Japanese charge before it reached American positions. Lawson fired 3 complete 8-round clips, 24 rounds in perhaps 30 seconds. He reloaded a 4th clip and continued firing at enemy soldiers who had gone to ground. The Japanese attack collapsed. Bodies lay scattered across the volcanic sand, most having fallen more than 50 yards from American lines. They had never gotten close enough to use their bayonets. The after-action report noted that Marine rifle fire had been the decisive factor in breaking the attack. Machine guns had certainly contributed, but the sustained fire from M1 Garands had prevented Japanese infantry from concentrating for a coordinated assault. Private Lawson survived Iwo Jima and later commented that he could not imagine having stopped the banzai charge if he had been armed with a bolt-action rifle. There were too many of them moving too fast. If I'd had to work a bolt between shots, they would have gotten to our position. The Garand saved my life. His assessment was shared by tens of thousands of American soldiers who faced similar situations. The semi-automatic rifle transformed defensive operations by allowing smaller forces to hold against larger attacks. Japanese tactical doctrine, developed for warfare against opponents with bolt-action rifles, became obsolete when facing Americans with Garands. Yet Japanese forces never adapted, continuing to employ human wave tactics throughout the war despite devastating casualties. The reason was simple. Japan lacked alternatives. Japanese infantry armed with bolt-action rifles could not win firefights against Americans with semi-automatic rifles. Japanese forces had to close to bayonet range or die at distance. Neither option offered much hope for success, but Japanese doctrine emphasized aggressive offensive spirit over tactical flexibility. The result was catastrophic Japanese casualties in every Pacific engagement. The disparity in weapons technology was so severe that it approached being a different category of warfare. American forces were fighting with mid-20th century technology. Japanese forces were fighting with early 20th century technology. The outcome was never in doubt. The Soviet Union provided an interesting counterpoint to both the American and German approaches. Soviet industry produced approximately 1.5 million semi-automatic rifles during World War II, including the SVT-38, SVT-40, and AVS-36 designs. This sounds impressive until one considers that Soviet forces totaled more than 11 million soldiers at peak strength. Soviet semi-automatic rifles equipped approximately 13% of infantry, compared to nearly 100% of American infantry. Soviet doctrine emphasized simplicity and ease of training. The Mosin Nagant bolt-action rifle was crude but functional. It could be operated by soldiers with minimal training. It required little maintenance. It was cheap to produce. Soviet planners decided that equipping more soldiers with adequate weapons was preferable to equipping some soldiers with superior weapons. The strategy succeeded through sheer numerical superiority and tremendous sacrifice. Soviet casualties exceeded 27 million, military and civilian combined. American casualties totaled approximately 400,000 military deaths. The vast disparity in casualties reflects many factors, but American equipment advantages, including the M1 Garand, certainly contributed to American forces' ability to achieve objectives with acceptable losses. Britain took yet another approach. British forces evaluated the M1 Garand in 1939 as a possible replacement for the Lee Enfield. British planners concluded that the Garand was too expensive and that Britain lacked the industrial capacity to produce semi-automatic rifles in quantity, while also manufacturing tanks, aircraft, ships, and everything else required for modern warfare. Britain chose to maximize production of adequate weapons rather than produce smaller numbers of superior weapons. The decision was pragmatic, given Britain's circumstances. British industry was stretched thin, supplying not just British forces but also Commonwealth forces across the globe. British factories operated under constant threat of German bombing. Raw materials were limited by German submarine warfare. Every pound sterling had to be carefully allocated. Adopting the M1 Garand would have required retooling factories, training workers on new manufacturing processes, and establishing entirely new supply chains. The disruption would have reduced total weapons production for months or years. Britain could not afford that disruption when German invasion was a real possibility. So British forces fought the entire war, armed primarily with Lee Enfield bolt-action rifles, a weapon that represented the pinnacle of bolt-action design, but remained fundamentally inferior to semi-automatic weapons. British commanders compensated through superior tactics, aggressive patrolling, and excellent artillery support. British infantry achieved remarkable effectiveness despite their technological disadvantage, but they paid for that effectiveness with casualties that might have been reduced had they possessed semi-automatic rifles. The handful of British units that did receive M1 Garands, including No. 1 Commando and No. 6 Commando, reported overwhelming satisfaction with the weapons and refused to give them up even when offered newer British designs. These commandos fought in North Africa, Italy, and Burma, armed with American weapons. Their after-action reports consistently praised the M1 Garand's reliability and firepower. January 31st, 1945. Hill 170, Kangao, Burma. Lieutenant Colonel Peter Young of No. 1 Commando watched Japanese infantry mass for what appeared to be a final assault on his positions. His 24 commandos had been holding the hilltop for 3 days against a Japanese battalion. Casualties had been heavy, but the position held. Every man in Young's command carried an M1 Garand. When the Japanese attacked at 0730, the commandos opened fire with devastating effect. The semi-automatic rifles allowed each man to engage multiple targets without pause. Japanese infantry, armed with Type 99 bolt-action rifles, could not generate sufficient return fire to suppress the British position. The attack collapsed within minutes, leaving dozens of Japanese bodies on the hillside. Young's commandos continued to hold Hill 170 for another week, repelling repeated attacks through superior firepower. The unit's historian later noted that without M1 Garands, the position would have been overrun on the first day. The semi-automatic rifles gave 24 men the firepower of 60 men with bolt-action rifles. That 3-to-1 advantage was decisive. Young survived the war and became a distinguished military historian. In his writings about the Burma campaign, he repeatedly emphasized that American weapons, particularly the M1 Garand, had been superior to British equivalents. He argued that Britain's decision not to adopt semi-automatic rifles had cost British infantry unnecessary casualties throughout the war. His assessment, while controversial in Britain, was difficult to dispute. The mathematics of firepower were undeniable. The M1 Garand's legacy extended far beyond World War II. The rifle remained in American service through the Korean War, where it again proved superior to opponents' weapons. Chinese forces, armed with Soviet bolt-action rifles and submachine guns, consistently lost firefights against Americans with Garands. Marine and Army reports from Korea praised the M1 Garand's reliability in extreme cold, its accuracy at medium ranges, and its decisive stopping power. The rifle was not replaced as America's standard infantry weapon until 1957, when the M14 was adopted. Even then, the M14 was essentially an improved Garand with a 20-round detachable magazine and select fire capability. The basic operating system, John Garand's gas-operated, rotating bolt design, remained unchanged. When the M14 gave way to the M16 in the 1960s, elements of Garand's design philosophy persisted. The emphasis on reliability, the gas-operated action, the focus on putting effective firepower in every infantryman's hands rather than concentrating automatic weapons with specialists. These principles traced directly to lessons learned with the M1 Garand. Modern military rifles from dozens of nations use gas-operated systems derived from Garand's original design. The AK-47, the M16, the FN-FAL, the G3, the AUG all employ variations of the same basic principle. Tap propellant gases from the fired cartridge and use that energy to cycle the action automatically. Garand did not invent gas operation. That principle had been explored by various designers since the late 1800s, but Garand perfected it for military use, creating a system reliable enough, simple enough, and robust enough to serve as the foundation for modern military firearms. His achievement becomes even more remarkable when considering his background. He had no formal engineering education beyond high school. He taught himself through correspondence courses and practical experience. He worked in a government arsenal on a civil service salary. He never became wealthy from his invention, never received royalties commensurate with his contribution to American military success. Congress debated granting him a $100,000 reward after World War II. The legislation failed. Garand received various medals and honors, but died in 1974, having earned no significant money from the rifle that bore his name. His story challenges assumptions about innovation and expertise. The American military establishment initially resisted his design. Ordnance officers with engineering degrees from prestigious universities dismissed the work of a self-taught machinist. Traditional manufacturers like Winchester thought his rifle was too complex to produce economically. Yet Garand proved correct, and his critics proved wrong. The rifle worked. It could be mass-produced. It gave American soldiers a decisive advantage. The institutional resistance Garand faced mirrors the resistance that Klaus Hartmann and other German engineers encountered when they reported American firepower superiority. German high command refused to accept that American industry could produce superior weapons. German military doctrine insisted that training and discipline mattered more than equipment. German commanders consistently underestimated their opponents until reality forced recognition. That recognition came too late. By the time Germany attempted to field semi-automatic rifles in significant numbers, the war was already lost. American industrial capacity had produced not just 4 million M1 Garands, but hundreds of thousands of trucks, tens of thousands of tanks, and a war machine so vast that German resistance became futile. The M1 Garand was one component of that war machine, but it was a critical component. It multiplied the effectiveness of every American infantryman. It gave American forces tactical advantages that compounded into operational and strategic success. It proved that semi-automatic rifles could be issued to all soldiers, not just elite units. The German engineers at Kummersdorf, who tested the captured M1 Garand in September 1944, understood what they were seeing. A weapon that changed the fundamental equation of infantry combat, a weapon that made traditional bolt-action rifles obsolete, a weapon that American industry produced in quantities Germany could not match even if German designers created equivalent designs. Oberingenieur Klaus Hartmann's report to Wehrmacht High Command acknowledged American superiority, but also noted that Germany lacked the industrial capacity to respond. That capacity gap was the real story. Germany could design excellent weapons. German engineers produced the Tiger tank, the Me-262 jet fighter, the Type XXI submarine, each representing cutting-edge technology, but Germany could not produce these weapons in quantities sufficient to affect the war's outcome. America designed adequate weapons and produced them in overwhelming quantities. The M1 Garand was not perfect. It was not the most sophisticated semi-automatic rifle ever created, but it was reliable, manufacturable, and available when needed. 4 million rifles armed American soldiers at the moment of greatest need. That was enough. The contrast between American and German rifle production illuminates why America won World War II. It was not superior fighting spirit. German soldiers were courageous and well-trained. It was not superior tactics. German doctrine was often more sophisticated than American doctrine. It was industrial capacity. America could produce more of everything. More rifles, more ammunition, more tanks, more aircraft, more ships, and sustain that production for years, while enemies' industries collapsed under bombing and blockade. The M1 Garand symbolized that industrial superiority. Every American rifleman carried proof that American factories could mass-produce complex weapons reliably and cheaply. Every firefight where American rifle fire overwhelmed German opponents demonstrated the advantage that industrial capacity provided. The 8 rounds that could be fired without manual bolt operation represented more than mechanical innovation. They represented American industrial might, translated into tactical superiority. John Garand changed warfare not through brilliant innovation alone, but through creating a design that American industry could produce in quantities that made innovation relevant. A brilliant rifle that could not be manufactured would have been useless. A mediocre rifle, produced in millions, would have been valuable. Garand achieved both brilliance and manufacturability, creating a weapon that was good enough and available enough to change history. The story that began with a Canadian immigrant teaching himself engineering in Connecticut mills ended with American soldiers carrying the finest infantry rifle of World War II. The story that continued with German engineers testing captured equipment ended with German acknowledgement that they had been outproduced and outgunned. The mathematics of firepower that showed one American rifleman matching 3 bolt-action riflemen translated into victory after victory in every theatre of war. September 17, 1944. Klaus Hartmann left Kummersdorf Proving Grounds knowing that Germany had lost the small arms race. The captured M1 Garand represented everything Germany could not match. American industrial capacity, American willingness to issue advanced weapons to all soldiers, American ability to sustain production despite the war's demands. The rifle fired 8 rounds without pause. German soldiers worked bolts manually between each shot. That difference, multiplied across millions of soldiers and thousands of engagements, became decisive. Technology mattered. Industrial capacity mattered. The nation that armed its soldiers with semi-automatic rifles defeated nations that armed their soldiers with bolt-action rifles. John Garand understood this. He designed a rifle that American factories could build in quantities that would arm every American soldier. That understanding changed warfare more profoundly than any tactical innovation or strategic doctrine. The rifle he created served American forces for 20 years after his death. The operating system he perfected forms the basis of military rifles worldwide 70 years later. His contribution to American military success in World War II cannot be overstated. 4 million M1 Garands gave American infantry overwhelming firepower superiority in every engagement. That superiority saved American lives, accelerated victory, and proved that semi-automatic rifles were not a luxury for elite units, but a necessity for modern warfare. The German engineers who tested captured Garands recognized this truth. Their reports documented American superiority. Their recommendations acknowledged that Germany could not match American production. Their conclusions accepted that the war's outcome was no longer in doubt. Klaus Hartmann's final report included a section on lessons learned for future conflicts. The nation that enters the next war with semi-automatic rifles as standard issue will possess overwhelming advantages. Industrial capacity to produce complex weapons in quantity will be as important as tactical skill or strategic planning. For all infantry represents a fundamental strategic error that contributed to our defeat. The report was classified and filed. It would not be discovered until American technical intelligence teams reviewed captured German documents in 1946. By then, the lessons it contained had already been learned through bitter experience. The age of bolt-action military rifles had ended. The era of semi-automatic and automatic rifles had begun. John Garand had fired the first shots in that revolution, working alone in his Massachusetts workshop, creating a weapon that would arm millions and change the nature of infantry combat forever. The distinctive ping of an empty clip ejecting became one of the most recognizable sounds of American military power. That sound meant 8 rounds had been fired in seconds. That sound meant an American rifleman had delivered firepower that 3 bolt-action riflemen could not match. That sound meant the enemy faced overwhelming fire superiority. German soldiers learned to fear that sound. Japanese soldiers died before they could close distance against it. American soldiers trusted their lives to it. The M1 Garand proved that one man with superior technology could match 3 men with inferior technology. The mathematics were undeniable. The combat results were decisive. The legacy endures. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.